This is for me my first time in South Africa and also in Cape Town. So far it's been really amazing. Love the country. But also thank you for having me in that sense, because otherwise I wouldn't have been here. My name is Pauk van Beckhoven. I work as a senior software engineer. I'm from the Netherlands, where I've been working for about 10 years, of which the last 5 in consultancy for various companies, including I worked on some COBOL things with Google. You imagine, whoa. But that's not what this presentation is about. But I also did an online supermarket. So all kinds of things, and the sort of the experience that I gained through all these consultancy jobs, I took them to Switzerland. So I decided to move to Switzerland, work for a company called Hexagon, and there I managed to sort of put all these learnings into practice. And the nice thing is that I actually realized that this really helped the project move forward. So why not just turn this into a presentation to help others as well move their projects forward? I really like code quality. I really like developer experience. That's also what I've been talking about for the past 7 years now at conferences. And I hope to learn you a thing or two about code reviews. I also work at Hexagon. I just realized or saw that I actually have colleagues here, which is pretty awesome. So I'll speak to you later. Yeah. So let's start. $316 billion is not my salary, unfortunately. But it is an amount that could solve a lot of world problems. Also not spent on that. No, it's the amount of money that was estimated to be spent on finding and fixing bugs in 2013, according to research done by students from Cambridge University. No, I mean 2013, so you can imagine there's been some inflation since, so we're spending a lot more money. Now, what we do know is that the longer it takes to find a bug, the more expensive it becomes to fix it. I think who have seen this diagram before or something similar? More or less, good. Yeah, I mean it kind of makes sense, right? When you find the bugs very early in the design, you fix them. It's very easy because you haven't built it. But if you figured it out once it's been running on prod for a long time, well, it costs a lot more to figure out what the problem was and to go back and to fix it. Now, with this presentation, as I mentioned, we're going to be talking about code reviews, which take place approximately in the coding and testing phase. And it's one of the things that we can do to spot bugs earlier than when they make their way to production. Now, what is a code review? There's many definitions out there. I like this one because it highlights that there's multiple parts of it. The first one is, of course, identify errors, right? We want to find the bugs and fix them early. But it's also about foster learning. It's about knowledge sharing, about training other newcomers in the projects to get them up to standards with the way the team's working, or also about mentorship, getting co-ownership. And it's about improving code quality. And I figured I'll give that one a definition of its own. It's about making, it's one of many definitions, and definitely maybe not the most true one, but to me, it's about making code more readable, it's about making it more efficient, in line with your company's standards and conventions and best practices. Now, this all sounds pretty great, right? Code reviews, good? Yes? Yeah. So, we don't need this. No. There's, of course, some nuances do apply. There's always cases in which you could argue against code reviews. Maybe you heavily invest into pair programming or in mob programming, or you do a lot of quality control up front. Then you could argue that it's maybe less useful. Last in Johannesburg, when I gave this presentation 2 days ago, there was also somebody who came up to me, yeah, but code reviews are also really expensive. They cost like 20-30% extra time to get your features through. Yeah, that is true. It's an investment you do to get more quality in return. And if you so if you invested in programming, it might not be so valuable, but I still think it can be very valuable, even if it would just be for knowledge sharing. Now the question is, how do we develop this or how do we incorporate this in our development practices? And that's what we have these things called pull requests for. We create a branch, and then we ask somebody if it can be merged, and if it's okay, then we merge it. I want to do a quick show of hands again. So who thinks it's called pull request, and who thinks it's called merge request? So pull request, that's a lot of hands. Merge request, let's see, GitLab users. So GitLab is one of the version control systems that's heavily pushing on the term merge request. I'm also working with GitLab, or at least my part of the organization is. And that means that my team has indoctrinated me into using the term merge request. They mean the same thing, they are the same thing, I don't care which one is right, but if you see me confuse the terms, my point is that I probably would mean the same thing. Now we have a lot of these version control systems out there, like GitLab was mentioned, but GitHub or Bitbucket or Azure DevOps. These are all great tools that facilitate us in creating and reviewing these pull requests. We can add comments, we have awesome integrations with other tools that can help already find some issues. We have We can integrate with our build pipeline, so we immediately see whether it actually is even working or not. And even though we have these amazing tools, we still often run into quite some issues. We have the pull request we create that changed 55 files on a project that has an amazing title and even better description, which also gets looks good to me and approval in 30 minutes. We have the awesome feedback that we receive from people where you'd argue doesn't make me much happier, or the fact that people don't really like the review and we are waiting endlessly. And last but not least, we have the curse of the small pull request, where we'd like to argue about the little things we can comprehend rather than the more complicated things. Now, the next question is, how do we address these issues? And I think this starts with for example, review-friendly pull requests. And for this, we're going to assume now we're going to skip the development phase, so all our changes are nice and concise and focused and tested. That's out of the scope for this presentation, and we're going to look at the pull request itself. But before we go there, I want to go quickly to one nice quote I really like by Robert C. Martin, also known as Uncle Bob. I don't know who've seen this quote before. Not that many? Okay, then take it in. It makes sense. It's about the time we spend on coding versus the time we spend reading the code. And it's true, right? We only write it once, but we probably need to read it 10 more times when we're making changes in that area. And this also goes for a lot of things. The same for when you write a message and you send it to a channel. There's 30 people reading it, but there's only one person writing it. So if that person puts in a little bit of effort, you can save time for those 30 other people. And that's sort of the theme I want to go in here. The more effort we put into our pull request, the more easy it is for the reviewers to review. So the title. Right, what makes a good title? A good title should be self-explanatory, like a good commit message. And fix bug is not a good title. But if we add a bit more context, we do have a good title. And I also mentioned it's like a good commit message. You could even argue there's this thing called conventional commits. For those who don't know, go look it up. It's a way to structure and standardize your commit messages to make them consistent. The nice thing about this is that you can also make it parsable and that you can lint it, which is great because then you can do automatic versioning based on your pull request title. If it's a fix, it's a patch version. If it's a feature, it's a minor. And if it's a breaking change, it's a major version. And what we often see is that these commit messages or these pull request titles, they end up in the change logs. It's also kind of nice to have those consistent rather than having them randomly around. And it's also good to enforce that you always have a ticket number in there so that you can click. Most tools allow you to click and go straight to the ticket, which gets you already some context. Then there's the description. Now, we want to start with adding a bit more context. Everything basically that doesn't fit in the title, which you can put there. Maybe links to documentation, maybe links to other interesting information, or when does this bug exactly occur. And we want to give a brief overview of what has changed, what can the reviewer expect. And typically this is the thing you just mentioned, but sometimes you do a bit more. Sometimes you refactor something, or you fix some other things, or you improve the tests, just to give a bit of an overview. And then the why. And with why, I mean, why did you choose a given approach, or why did you do things in a certain way? For example, when you're implementing, you might consider different parts, and you might consider a synchronous solution and asynchronous solution, and it turns out that the synchronous solution is much better. You tried the asynchronous solution, and you probably come to a conclusion that it didn't work. Now, as soon as you merge this thing, this knowledge is lost if you didn't write it down. So if you just write it down, for example, here we chose synchronous because asynchronous didn't work because of this. It's knowledge that the commenter doesn't have to, the reviewer doesn't have to ask about. And you at least remember next time when somebody asks a year later, hey, why did you do it this way? You can still find it if you look to the pull request in which it happened. Then we add some examples, right, to make it visualize, to make it sort of graspable what changed. For front-enders, I don't know how much people do here are in the front-end side of things. The front-end? Back-end? Oh wow, that's very different from Johannesburg. I don't know why that is, but I'm also from the backend. So, but for the front end, it can be screenshots or videos of the new feature. But for the backend, you can add example requests and responses so that people can immediately see what's going on there. And then please don't do screenshots, but actually copy and paste so that people can copy and paste again to try and see if it works. Or database queries or anything that could help make it easier for the tester as well. And then the challenge is, of course, nobody likes a big wall of text. We want to keep it readable and concise, so we want to structure it a bit, and maybe ChatGPT can help us make it more readable. What also helps is templates. I really love templates. They help you structurize the text, so whenever you create a pull request, most VCS tools allow you to set up a template that we always have to fill in. That means that you immediately know which information to find where, and what I specifically like about this is the use of checklists. So I tend to forget a lot of things. If it's not over the weekend, it's over the week. And that also means that I kind of forget about certain procedures. Like, for example, what you have is the changing, maybe there's some architecture diagrams that need to be updated at the end of some change, maybe added some new database table. There's often only 1 out of maybe 10 changes. The other 9 are fixes and refactorings, and then it's not really relevant. So just as a brief reminder can be there, oh right, the architecture diagrams, they exist. But it can also be other parts, maybe the release notes need to be updated or somebody needs to manually add something to the change log. Effectively, you can tailor this to your company's needs and put anything in there that you tend to forget as a sort of, and you cannot really automate yet, because ideally we would automate this, right? If no change log has been added or edited, we just don't pass. Or we do it automatically, not even better. Right. The next step is that we're gonna be the first reviewer. So we created this nice pull request. I also wanted to add that, of course, not every change needs this whole documentation. If you're just fixing a minor thing, you don't need to do a why and what change, it's just noise. But I think every change always deserves some explanation. I've seen it before that you just upgrade a minor version of some library, and that's the pull request, patch version, or patch library. But you patched it for a reason. You patched it because maybe you can now parse this new file format. And it makes for the reviewer so much more easier if you just quickly explain that. It's one line, it's 30 seconds of work, but for all future versions of you and other developers, it's super nice to understand, okay, this was because of this, rather than having to go to that library, try to figure out what changed. That's why. Now, we created a pull request. We're also going to be the first reviewers. The reason why is that we have a sort of a new, different perspective on the code. Instead of having watched it at our editor for a long time, we're going to now see it in a sort of a diff view, which also gives us, it focuses on the change itself. So where we previously, maybe we were making some changes, we tried different solutions, and then we moved from one solution to another, and there's some leftovers. There's still some unused methods, maybe there are some poor method names, maybe there are some to-dos, maybe some parts where if you look at it again, ooh, this is not really pretty. When I do this, I always find things. The more changes I made, the more things I find, and the more commits I can do that already sort of improve my pull request without having to bother reviewers. What you can also do is start commenting on your own pull request to make life easier for the reviewer. There's always things that might make sense within the code, but if maybe you move the method from A to B, or you split it into 2, from the diff, it looks a bit weird, right? Something disappeared here and 2 things appeared there, and now we have to infer what happened here. If we just add a simple comment there saying, okay, we split this up and moved it there, now the reviewer immediately knows what's going on. Or maybe in this case, I found a file that was not used anymore, but I tried to figure out when would we stop using it. So I did some research. Now write it down, because that's useful for the reviewer as well. They don't need to do this research again. And you can highlight important parts. So maybe there's things that if you do bug fix, but you also formatted it, and the person before you didn't format it. Now you have 20 lines changed, but only one of them is relevant. You can just highlight, okay, this is the bug fix. The rest is just, maybe I renamed something to improve it. We can also ask questions. Maybe we're insecure about certain parts or uncertain things that can be improved. Hey, I don't really like this name. What do you think? Should we maybe go for this? It's a nice place to start a discussion already for the reviewers, so that you don't really need to ask them. You immediately can ask them in the context. And now it's done. We need people to review. And in the ideal world, you don't have to ask for reviews. People will just proactively look at the open pull requests, or they immediately get assigned to pull requests and then proactively start reviewing. In practice, it's a message that's been thrown in a channel with 30 people. And people are not very keen on reviewing because it takes them away from their current task. They have to switch context, and maybe they can't find anything, so they're like, it's just a waste of time. But yeah, sending this message in also is not really efficient. Because this will work the first time maybe, but the 20th time I think people are a bit tired of the kitten. And the reason is that if you throw that in a channel, there's 20 people, they all think somebody else is gonna do it. And the next day they're all be, I picked it up yesterday, somebody else will do it. And we all point around and nobody does it. So what does help is to target specific people. Just tag somebody of the team that's supposed to review. Just a random person, because if it's not the right person, they will redirect you to the right person, as they don't want the responsibility. And what can also help is to add some context. What is the change about? Because it might immediately signal people that are working in the same area, like, hey, I can expect some merge conflicts there. Maybe it's good to first check this, so that, because if I continue, the merge conflicts are only going to get worse. or because I have the context fresh. And also some deadline, like some sense of urgency. Maybe it's something really important that needs to get through, then maybe it's good to signal that there as well. But also if it's not important, like, hey, can we get this done by the end of 2 weeks so that people can plan accordingly and know they don't need to drop their work immediately. So a message like this is much more likely to get some traction rather than yet another, hey, here's the link message. And this goes beyond asking for reviews. You could argue that whenever you need something from another team, you need to drop in their channel, hey, can somebody from the DevOps team help me with my dev environment? If you just tag a random DevOpser, you probably get quicker response, and they will either redirect you to the right person. So it's a more common thing. Just try to target specific people than randomly throwing it in a bowl of people. So now people will start looking at our merge request, of course. There we go. Which doesn't always go as expected. Some people simply lack social skills, or maybe they are not aware of the tone they use. And this is maybe a great opportunity to give them that feedback. There might also be cultural differences at play. So we, the Dutch, are known to be quite direct, which is not always appreciated. Yeah, I don't know why, but why do you need all that fluff? But that means for me, it's a waste of time, come on. No, so for me, that means that I probably might need to add some fluff around my message. But what I want to move toward is that in the end we all want to be professionals, or we are professionals. And it also means that it's more about the message, right? We want to fix this change, we want to review it, we want to merge it, and if now it's the tone of voice shouldn't get in the way there. So ideally we give them feedback, but don't try to start a fight over the tone. It's about being patient and also try to be the bigger person. Okay, we want to move forward. So there will also be feedback that will not be very useful. And it's quite annoying, because what does this mean? And we can go back and forth, try on error, try to figure out what this means, reread it for the 10th time, try to see if we by then figured it out. But it's quite wasteful. Instead of doing that, just ask for clarification. It's really not bad to ask for clarification, because probably the person who wrote this command should have put in a bit more effort. And then we have the endless discussion. Ideally, we pick our battles, but it may happen that both parties decided to pick this battle. And then it can get quite lengthy. And the annoying part about the discussion in a pull request is that it's asynchronous and it might last like a whole day, which means both of you are constantly sort of back and forthing every half an hour, and it's horribly inefficient. Try to take it offline or online, but at least in a synchronous discussion. And then the important part is to always report back, because we've all been there, that we were looking for this problem on Stack Overflow, and we finally found somebody that had the same problem, but then nobody ever answered or gave the solution. It's really annoying. So always try to report back, and not just what was chosen, but also why it was chosen, so at least you have some understanding. But hopefully it will not all be bad. In the end, there will also be improvements. We will decrease the number of bugs, or we will improve the readability. And we might also learn things. So rather than always saying fixed or awk or done, try to show some appreciation. Also when somebody's new, maybe you have a junior on the team that's just started with doing some reviews, give a compliment here and there. They might start asking questions, and rather than sort of doing a very direct answer, we the Dutch, try to say, oh, that's a good question. Hey, yeah, it's over there. Just to sort of compliment, give them a bit more, what's the word I'm looking for? More confident. And more confident means also they're more likely to review again. Because if you burn them down in the first review, they're not likely or very insecure to do it again, which not optimal. So we've done the reviewing. We've been reviewed. Now we're gonna do the reviewing. And I think the first part, what's very important, is to don't wait too long. The longer it takes, the more time is lost to merge conflicts and switching context. And what you can do about this is to just start the day with a review. Because then you're fresh, you don't have anything you're working on, spend the first hour unblocking other people to let them get on with their work, and so then you can also get on with your work. Or whenever you pick up a task. So ideally, our backlog is sorted by priority, and the most important tasks are at the top, which also means ideally that whenever we're going to pick up a new task, that's going to be the most important task, and the ones that are already being picked up are even more important. My point being, the tasks that are in progress are probably more important, so we should review first before we start a new task. Ideally, because we don't want this whole 20 tasks in progress, we want to keep focus in the sprint. Then the other part is about taking responsibility, and I put this in bold because this is a personal frustration as well. We've often seen people using code reviews or see them as just a way to unblock others. Right, it needs approval. Okay, approve, and then we can merge, we can continue rather than looking at it. The 55 file change that I mentioned in the beginning, that pull request is horribly undescriptive, still gets an approval in 30 minutes. That you cannot comprehend that in 30 minutes, which means you didn't do a good job. To me, it's about taking responsibility. You sign it off effectively. You become the co-owner of the change, which means that you need to understand what's going on. You can't just look at the dot commas and the line breaks on the right place. It's fine. No, but you don't understand. Maybe the parameter is now nullable, and if it's null, it's going to go down. It will cause a null pointer exception. Java. Yeah, I'm a Java developer. But there's many things that can go wrong. So it's about taking responsibility. So whenever I review, I want to comprehend. And if I don't comprehend, I cannot approve. So I need to understand. Now when we start, we want to get the context. So we just put in quite some effort to creating this nice description. We should also read it. Because I've also been like Sheldon many times that I went straight into the code, found some silly little things where I'm like, why did we do this? And then like halfway typing the command, I go back to the description to just double check. And then it was there. It's a bit wasteful of the time that I went into just read the description first. Also it goes two ways. So if there's no description whatsoever, that's maybe you could just ask them to write a description first rather than trying to reverse engineer it from the changes that were made. It's a bit wasteful of your time as well. And also check the existing comments, because it's very annoying to have the same discussion in multiple places or see what has already been commented on. And then when we start reviewing, we start from the top. So we first check the design. And then the reason is that from the top, because whatever we find at the top will trickle down. So if something needs to be rewritten, maybe something needed to be asynchronous while it was synchronous. And of course, this probably should have been signaled before, and you should not notice this only when the pull request is being created. But if you need to change it, that means that you need to change the code underneath. So if you start giving commands on the code style somewhere underneath, yeah, it's going to be written anyway, so that's kind of useless. So you start with the design. You go over a step deeper, like the functionality. Did we cover all the scenarios, the happy flow, all the unhappy flows mostly? Is the code readable, and can it be implemented in a simpler way? Maybe we used the wrong framework here and there. And then we start looking at the tests, which also deliberately made bold, because tests are the thing that often get the least amount of attention during development, and then even less attention during the code reviews. The reason mostly being that the tests are often at the end, so we first review all the code, we just went over 10 files, and then there's the test file. Yeah, the test passed, right? But the problem is that a bad test suite will also affect you. If you miss, somebody forgets to add more assertions, there's an endpoint that returns objects, and you look if the right object was returned. So you only check the ID, and you didn't bother to check the description and some of the other fields. If I now accidentally remove something there, it won't be detected by the test. And this is also how I've introduced bugs here and there, because a missing assertion can be an opening for a lot of bugs. So try to spend some time on also checking if the tests make sense and if the tests are readable, because tests can get real messy really fast. And then at the end, you can start nitpicking on all the line breaks and things that don't really make a big difference. And there's tools that can also help you with reviewing. One on the left, what you see here is for example GitLab. In GitLab, and I think there are some other tools that can do this well. You can show the code coverage in the diff. So you're going over the diff of the change, and you can see if the lines were actually covered or not. So who here has code coverage in their diffs? Ooh. Right. Especially for the backend. I can understand that for the front enders is already a different story, because you don't want to unit test your HTML. I don't think it's even possible. But for the backenders, ideally, we want to have a lot of proper code coverage, which means that whenever we do a code review, we also want to see if it's covered or not. And we're not, even though we say we might do it, we're not going to go over the code coverage report and then put them next to the diff and then go back and forth to see if it was actually properly covered. So if you get this in your VCS tool, I introduced it, and when I started using it, I found it super useful. You can spot unused codes quite easily. Right? I found some code that was not tested. Turns out it could be deleted because it was a leftover. There's also Sonar that you can add as an integration to already start adding some command. But there's one tool that we all have access to, and that's our own editor. So just quickly assume, so who here are Java developers? Oh, wow, it's also much better than Johannesburg. I like this place more. No, so this is just, I mean, it doesn't really matter whether it's Java or not. It's about the fact that I made a small change and that my diff tool, my VCS, my GitLab, doesn't show me all the context. Because if I would open this in my editor, I could immediately already start seeing something. There's a constant that's now being unused. In Java, we can do string compare. Check if a string is empty in two ways. We can check if it's equal to an empty string, or we can ask the string whether it's just is empty. And that's what the suggestion would be here. But we can also run the code coverage I just mentioned. We can also do that in our editor. We can run the tests with coverage, and then we can also see whether some new bits have been covered or not. So my GitLab maybe not tell me the whole picture, but my editor does. So I typically try to use the GitLab or the GitHub to get a bit of an overview of all the changes that were made, and then I quickly move to the editor to see the code itself, but also because it's easier to navigate around. I don't know if some of you know that even in your VCS tool, there's actually a hidden editor inside that if you press the dot in GitLab or GitHub, it will automatically open a cloud editor. It's really nice if you quickly want to move around files. Just a small tip. Now, while editing or while we're reviewing, we're going to find things. And we're going to probably have some comments about that. And there's a couple of things that I would like to give as a hint. And the first one is so we have this message here. You chose the wrong framework, used X that is actively maintained. I think there's two problems. The first one is the word you. You did something this. This can be quickly it feels like you're being attacked. It can be interpreted as a direct attack, which makes people defensive. And when people are defensive, they're also less likely to cooperate and willing to change. So try to stay away from the word you. Go for we. We is about collective ownership and collaboration. Even though, of course, I didn't make the change, sure, but we as a whole are working on this, and we as a whole are working together. The same for statements. If I make a bold statement, I don't leave any room open for somebody to explain what happened. Maybe there was a reason why X was not used. So if I would turn this around into a question, people again are much more likely to cooperate. Plus the added benefit is that I don't look like an ass when I'm wrong. So try to not use you and try to ask questions. It's so much more friendly and it leaves space for discussion. Then there's a couple of more things. We already mentioned the vague comments. Try to be specific. Try to stay away from words like this or it, because they often have multiple interpretations possible, which for you might be clear. The next time you reread it, you might also figure out, oh, this can also refer to the other line. And if there's multiple interpretations possible, that also means that there's a chance for miscommunication and time wasted on the wrong possible interpretation. So always reread your comments, and that goes beyond pull requests. It's reread your code, reread your messages before you send something. Again, going back to the write once, read many times. Just put in a little bit more effort, and it saves time on the reader side. Also good to add some explanation, like don't just say it's wrong, we should check if it's not null, but hey, it can be not null because of the way we put it all the way from the request down. There's always an explanation maybe that might make it more clear why something needs to be changed, especially if somebody's new to the project. And also try to provide alternatives. It's easy to say that the method, the name of a method is horrible, but it's really hard to actually try to give them a direction in what it should be or why it's bad. So try to provide some alternatives. Then there's suggestions. Most VCS tools allow you to sort of inline suggestions. If you haven't used it yet, I would definitely recommend it, especially for the smaller changes. So in this case, we're making an argument that we should use is empty, or when we're making changes to the documentation. The advantage here is that the author doesn't have to go back into the code and change it manually if they click the apply suggestion button, and the reviewer doesn't have to go back into the code to check if it was done properly because it was done exactly as wanted. The disadvantage is that this is quite stupid in the sense that it doesn't add or rename all the other parts that you've suggested, or it also doesn't add new imports that maybe are needed for the code you suggested. So it also does come with some, you need to be a bit aware of that caveat. Then there's something else that I came across. Besides conventional commits, there's also something called conventional commands. I tried it, it's fun, but it's also a bit extra work. I don't think it's super useful. The most useful part that we can get out of it is, I think, classifying relevant commands to nitpicky commands. In this case, they use the nitpick tag, and then as a team you can have a discussion about, okay, if we get a nitpick comment, it's up to the author to decide whether they want to go with it or not. So it's sort of a, hey, I think you can do it better by doing this, but if you don't want it, it's also fine. I'm not going to start a battle. do as you please. And last but not least, also just as we did with receiving feedback, it's also when giving feedback, try to find some positive parts. It's something. No, there's always something, right? Maybe you're happy about the feature, maybe something, the pull request is really nice and concise, maybe somebody really put in some extra effort on the test, you learned something new about this framework, you didn't know about this way of chaining methods. There's always something you learn, often, not always, of course. But try to write that down as well. If you're just thinking it, just be positive also in the pull request itself. Hey, I like that you added these tests here. Hey, good that you also thought about this part. I actually would have forgotten myself. It adds a layer of friendliness, because otherwise a pull request is only hearing what you did wrong, which is kind of, yeah, not very positive. Though often still useful, but especially in the time where there's a lot of imposter syndrome, also with juniors starting, it helps to also add a bit of a positive spin to it and tell people what they did right to increase the confidence. And also a happy people is a more productive, or a happy team is a more productive team. So in that sense, a bit of positivity will always work forward. Right, it's warm, but we covered the pull request part. There's another topic I want to talk about, which is called bike shedding. And this is not just a thing that the Dutch do. There's more people that do bike shedding. Bike shedding is also known as the law of triviality, and it's about spending a disproportionate amount on things that are easy to comprehend rather than on a complex problem. I think the term comes from some architectural discussion, from some architectural board that spent more time discussing the bike shed of their office than the complex power plant they were supposed to discuss. And this would be an example in my definition of bike shedding. Like, these two are equal in Java. This doesn't matter which one you do. It's purely about readability and opinion. Whether you do one or the other, the only argument you could make is that it's good for consistency. But ideally, we can automate all this away, because all these little comments, also about line breaks and everything, they add a lot of noise. This noise sort of distracts us from the bigger picture. If we're already annoyed on line 1 by, this import is unused, this should be done differently, a lot of these things can be automated away. And I think one of the big ones is, for example, formatting. We can often have a lot of discussion about code style and about line breaks and about code not being formatted. One of when I joined the team I was in, they had code style, they had some settings, but they didn't enforce it, which meant that half of the team didn't format and the other half did, which sort of skews in a pull request. If you see a diff, then one had few changes and the other one now was changing half of the project because people were not formatting and they did format. And the result was that whenever there was a new pull request, I opened it, I checked it out locally, formatted the change files, and pasted the change files back into the pull request, which is arguably quite wasteful if you have to spend 2 minutes every time. Well, it can be easily automatically enforced. There's plenty of formatters out there. In the event, we also did it. Ideally, you have just a formatter or a linter that's super opinionated, because it just gives no room for discussion. The downside of that is that it might also be wrong. It might also be suboptimal at times. But it's also a bit of getting used to it. I think we all know that when we join a new company, we don't really like certain bits of style, way they work. Then when we move to the next company, we also don't like it and we sort of want the old one back. It's about taking the pain, you go through it, and then you're done. Now, there's a lot of tools out there. I know Spotless is one that, especially in the Java world, works, but it's about the build system. I think there's other tools as well. The point being, there's actually a lot of languages typically in your project. And there are tools available that can help you automatically format them and automatically enforce the formatting in all kinds of language. We all have JSON files in there, some XML, and maybe some YAML, and some other languages. Now, there's another tool, Arch Unit. So who's .NET? .NET? Do we have .NETers as well? Okay. It's good. Not too many. No. This tool is also available for .NET. For other languages, you can sort of play around with. The idea is that we all have certain architectural guidelines in our project, and there's ways to enforce this for unit tests. So with Arch Unit, what I can do is I can define layers based on packages typically, or namespaces. And ideally, right, we have your controller, our service, and a persistence layer. Persistence should never touch anything from the controller. It's always down, not up. And with this way, we can enforce it. And there's more that we can enforce with these kinds of tools, like naming. What One of the less nicer things about Java is that we don't really have a standard on how to deal with interface and implementations. So whenever we have a service, we have a tendency to also create an interface it for just in case when the moon and the sun align, we might replace it with another implementation, which most likely we are not. But it means that, yeah, how do you call this? Does the interface start with an I, or does it end with interface? Or does each implementation end with impl? In the end, it doesn't matter, but it's good to be consistent about it. So if we can automatically enforce this, we don't need to have this discussion or even look at it in pull request because we know it's done. So that reduces the noise. Or if it's a controller and it's annotated with a certain annotation, it should probably have a name ending with controller. So these tools often come with a large set of predefined rules that help you capture the common mistakes. So I would advise you to sort of combine these rules in a centralized module so that you at least have them consistent across all projects, ideally within the company. Now, normally I give this presentation at Java conferences, so there would cover a lot more Java tools. So if you're curious about more tools for Java that can help you enforce the bike shedding, send me a message on the Current Actions app or somewhere else, or check out my presentation at any other conference, and then you'll find also a lot of other tools. When you find new tools that can help you automate parts, try to start small, start with one repository and involve the team as well. Because it's really easy to say, okay, we now enforce all these rules, merge, and then the next person comes in and now their build fails and they get really annoyed, and you'll be the person they come to constantly. Because if you involve the team, you create a sample pull request, you start commenting on it to explain which changes are why, and use that as sort of a log for the discussion. So in the end, everybody agrees on it, or if they haven't reviewed it within a week, they silently agree with it, and you use that to sort of create discussions. Then you want a baseline, so not that whenever the rules are introduced, now everything fails. Ideally, you want to introduce the rules while fixing the baseline. A lot of tools can already help you with this. So for example, if you want to enforce formatting, make sure that when you activate that rule, you first make sure that all the projects are actually formatted. And centralize the configuration. As I mentioned, you want to keep it consistent. To conclude, really try to spend a bit more time on your pull requests, review them yourself to fix the first issues. When you communicate, try to be specific, and also definitely try to be friendly and find the positive things, both as when people give you feedback as when giving feedback. Your VCS tool is pretty awesome. They have a lot of features. Try to see if you can use them to improve, and stop with the bike shedding, try to see what you can automate away. And that's it. Thank you.